Dear students, in this session we are going to see the symmetric cryptography examples, that is data encryption standard. The other algorithm is AES. The first one is DES. What is DES? DES is nothing but data encryption standard which uses symmetric key cryptography. What is symmetric key cryptography? If you are going to use a same key for the encryption as well as the decryption, then it is nothing but symmetric key cryptography. Examples of symmetric key cryptography are AES and DES, and asymmetric key cryptography is RSA, etc. Okay, so we'll see now what is DES, how it works. See, in DES we are going to use block ciphers. Here the data is divided into, the text is divided into blocks, and then the encryption process is applied. That is why it is called as block ciphers. So if you take block cipher, the block size should be mentioned. Then the block size is 64 bits here. Then key size is 56 or 128 bit. Fecal cipher plus an initial and the final permutation. What is fecal cipher? Is nothing but a combination of permutations, and the substitution is nothing but fecal cipher. Why we need this combination of permutations and the substitutions is to rearrange the data, to make the data complicated and then encrypt the data, so that it will be very difficult, it will be very complicated for the unauthorized person to get the data from the network after the encryption process is over. So what is DES totally? The process is the combination of initial permutation, 16 rounds of a function, 32-bit left-right swap, plus the final permutation. If all the four things are done, we will get a output with the cipher text. So what happens with this DES? We'll see with the help of the diagram. You are getting the data which is of 64-bit block, and what we have to do is we have to divide it. The first step is, as we said, it involves only 4 processes. The first one is initial permutation, and the second process is 16 rounds, applying the function for the 16 rounds, and the third is left right swap, and the fourth one is final permutation. These are the 4 processes that will be happening in the DES encryption and the decryption. Okay, what is initial permutation? So it is nothing but a rearrangement of the bits. That will be the initial permutation. Then the second process is what happens in the 16 rounds. See, in the after the output from the initial permutation, what will happen? It will go to the second process, that is round 1. In the round 1, before entering into the round 1, the data which is of 64 bit is should be divided into 2 parts. One is leftmost part and the second is rightmost part, which is of 32 bit. If you see here, leftmost part is 32 bit, here rightmost part is 32 bit. This leftmost 32 bits are taken and it is fed into the XOR operation, and the rightmost 32-bit data is taken and it will be fed as the leftmost part or leftmost bits for the round 2. This fed as the input for the round 2. Then what happens? This rightmost bits, 32 bits, will be fed into the function. The key, for every round a separate key will be generated. So 16 different keys will be given for the every round. So the rightmost bits will be fed into the function. Function is nothing but some mathematical operation will be happening. I'll say what and all mathematical operation is going on in the function. So with the help of the key, the input for the function is 2 things, that is rightmost bits and the key. After applying some mathematical operation or some operations, the output will be there. That output is XORed with the leftmost bit, leftmost 32 bit, and this output will be sent as the rightmost 32 bit for the round 2. Okay, so the similar things, the same process will be happening in all the 16 rounds, and finally when it reaches the 16th round, it will go to the third process called left and right swap. Okay, Now we said in the second process we are just dividing it into two parts, that is leftmost 32 bit and the rightmost 32 bit of the data, and the rightmost 32 bit is sent into the function along with the key, whose output will be XORed with the leftmost part, and the output of the XOR operation will be sent as the rightmost bit for the second round or the subsequent rounds. Okay, so what happens in this function? If you see what happens in this function, there are four things. One is expansion, and the second process is round key, XORed with the round key, and the third one is substitution, and the fourth one is permutation. As I said, we'll be having 32 bits. This 32 bits is expanded to the 48 bit. That's what happens in the expansion process. 32 bit is converted to or expanded to 48 bit, and it is XORed with the round key, which is of 48 bit. Then substitution. What happens in the substitution is 8 6-bit chunks are substituted with the 8 4-bit chunks. Now it is getting reduced. 8 4s are 32. Here it was the output of the round key operation was 48 bit. So it has to be converted again to 32 bit. So what they are doing, 8 6-bit chunks are substituted with the 8 4-bit chunks. 8 4-bit chunks. So we'll get the output after the substitution. We will get the data which is of 32 bit, and again it will go to the permutation process, that is rearrangement of the bits. The columns and the rows will be shifted, then we'll get this permutation, mix of rows and the columns. Okay, so these are the four operations that is done in the function which we said in the above diagram. See, in this function there are four operations happening, that is expansion, round key, XOR with the round key, substitution and the permutation. After that we will get the value, 32 bit value, right? That 32 bit value is XORed. Then we will get another 32 bit value which will be getting as the input, going as the input to the subsequent rounds. Okay, so what is this function? Function is nothing but again four operations will be done in the function. That is expansion, XORed with the round key, substitution and the permutation. So similar, the same process will happen in all the 16 rounds, and we will get the 64-bit output. How? This 32, leftmost 32 bit and the rightmost 32 bit will be combined, that is 64 bit will get into the third process called left-right swap. What is left-right swap? The left part will be going as the right part and the right part will be going as the leftmost bit, that is left right swap operation. Then comes final permutation. Again rearrangement of the bits will happen, that is mixing of rows and the columns will happen. Then we will get a final output, that is 64 bit, which is nothing but the ciphertext. The ciphertext will be moving through the network to the destination, and at the destination also the same process, reverse process will happen. So again permutation, left right swap, then 16 rounds. After that a permutation will happen, then we will get a plain text. So decryption process will happen at the receiver side similarly. So this is how this works. It is very simple. As the number of rounds and the length of the key increases, we can make the things more complicated and more secure. So with this, I am ending the session. Thank you so much. Bye bye.